You know that feeling when your phone just gets you? How AI seems to understand the nuance of what you're saying, not just the literal words you type? Well, today, we're going to decode AI's secret language. Okay, let's dive right in. For AI to understand our world, it first had to crack a very human code: context. And really, it all boils down to one simple question.
For us, that's obvious, right? We just know. We've spent our entire lives learning about royalty and language and how the world works. But a computer, it just sees a string of characters. It has no built-in understanding. To a machine, king and queen are no more related than king and beehive. So to get past this, to bridge this huge gap, AI needed a really clever trick. It needed a way to translate meaning into the only language it truly understands: math. This is where it gets really, really cool. We're about to pull back the curtain on the two key concepts that let AI turn these abstract ideas into cold, hard numbers. First up, the first piece of this puzzle is something called an embedding. Now just think of it like a universal translator, but for concepts. It can take pretty much anything, a word, an image, even a sound, and turn it into a unique numerical fingerprint that captures its essence.
And yeah, that's the key takeaway right there. An embedding is the bridge. It connects our world, full of meaning and context, to the computer's world, which is all about numbers. It's such a simple idea, but wow, the consequences are just massive. So if the embedding is the process of doing the translation, the vector is the final product. It's the actual string of numbers that comes out at the end. It's what gives every single concept its own unique address in this map of meaning that the AI is building.
So a vector literally just looks like a list of numbers. And when a computer reads a word, it's not seeing letters like we do. Nope. It's seeing a single point in a gigantic multidimensional space. I know, that sounds a little abstract, right? So let's bring it back down to earth with an analogy we can all get.
I want you to picture a world map. The way we find cities on a globe is actually surprisingly similar to how AI pinpoints the location of an idea.
Now, what's so cool about this is its simplicity. We can find any city on the entire planet with just two numbers: latitude and longitude. That's it. Those coordinates tell us exactly where a city is, and just as importantly, how close it is to other cities. Well, vectors do the exact same thing, but for concepts.
So instead of a physical map of the world, AI is building what we call an embedding space. A better way to think of it is a map of meaning. And every single word, every phrase, every image gets placed on this map based on its vector coordinates.
And this right here, this is the golden rule. This is the single most important rule of this entire map. Things that have similar meanings will have similar coordinates. They'll be neighbors on the map.
So let's put it all together. On this map, the vector for king would be sitting right next to the vector for queen. You'd find bee and beehive clustered together too. But the distance between that king group and the bee group, it would be huge. Proximity equals relationship. It's honestly that simple.
But, and this is a big but, here's where things get really mind-bending. Our world map has two dimensions, latitude and longitude. Our physical world has three. But AI's map of meaning, it has thousands. And we're not talking about a few extra dimensions. We're not talking 3 or 4. Modern AI models are using vectors with hundreds, sometimes even thousands of dimensions to map out the world of meaning. It's incredible.
So you're probably asking, why on earth do you need so many? Well, it's because each one of those dimensions can represent some subtle, abstract quality. Imagine one dimension measures royalty, another measures gender, another could be living versus non-living, or maybe something super specific like canineness. By plotting a concept across thousands of these different attributes, AI can capture these incredibly subtle relationships. It can understand not just that a dog is like a cat, but how it's like a cat, and also how it's totally different from, say, a lizard. That's the real power of this high-dimensional space.
Okay, I know this might all seem super theoretical, but I guarantee you are interacting with this map of meaning every single day. Let's look at just a few examples where this tech is already running the show.
You know that product recommendation that popped up when you were shopping online? That's Embeddings, the translation app on your phone that feels like magic. Yep, that's Embeddings again. And that chatbot that seems to just understand exactly what you're asking? You guessed it, it's all powered by Embeddings.
All right, so let's do a quick recap of the most important ideas from all of this. If you're studying for a test or you just want the key points to really stick in your brain, this is the part to pay close attention to.
Okay, number one, embeddings are the translators. They turn concepts into numbers. Number two, vectors are the actual coordinates that place a concept on that giant map of meaning. Three, and this is the big one, on this map, distance is meaning. The closer the vectors, the more related the concepts. And finally, this whole system is the engine humming away under the hood of so much of the AI we rely on every day, from search engines to recommendation systems to GenAI.
And that leaves us with a pretty fascinating question to think about, doesn't it? We've given machines a way to map out and understand the ridiculously complex relationships in our own language. So what happens when we apply that same technique to map other things, like human emotions, or complex scientific data, or even different artistic styles? The map of meaning? It feels like we're just beginning to draw the borders.